Hello to everybody. In this tutorial we are going to see how to interpolate your data from one grid to another. This operation is known as remapping and is implemented in CDO in the command remap. I prepared two files that we're going to use. So the first file is an output of an ocean model, MPOM, and is the potential temperature, so theta O here. The second file is a reanalysis product, the aura reanalysis, and is the temperature. The temperature. First step, let's look at these files. So the npm file here. Here the first level. So this file has two levels. One is at 6 meters and another one is at 310 meters, and also has three time steps, so I can go through and also the time steps. And okay, so this has multiple level and multiple time steps. I choose these files to show you how this interpolation works also for different level and interpolate different time step. Moreover, I choose particularly npm output because the grid is irregular, and so you can see that even just if you want to plot this data, you may need to interpolate on a different grid. So now let's look at the aura data. So t underscore aura NC. I'm using NCView again. Okay, if we plot aura, we can see that we have a long lat regular grid. I can plot the two together so that you can see the difference. And so you can see on the right a curvilinear type grid, and on the left a long lat regular grid. Okay, so our goal is to interpolate this data on a regular grid. The first step is to build a file that contains the description of the grid. So the command we're going to use is CDO grid des. CDO grid des return the description of the netcdf file, the grid description with the netcdf file. So if you do that with the npm file, we see that it will tell us that the grid type is curvilinear, grid size, and other information. As you can see, there are a lot of numbers. Those are the coordinates. In this case, I believe is longitude for each grid point, and this is quite a big file. Now, if we do the same for the aura grid here, we can see that the description is much shorter. Why? Because as it is a regular grid, we don't need to store all the coordinate of each point, but it's enough to know the resolution and the number of grid points and the reference point and other, and basically that's all. So okay. So what we are going to do now is I'm running again this command, but this time I am redirecting this output in a text file. So I will call it aura.grid, grd. Okay, I'm doing that, and now I should have one more file, and actually there are three files. I look at what the content of aura grid, and this is the content. So now this file contains the description of the grid that I will use during my remapping operation. So this is also, we can call it as target grid. Let's now interpolate our data with CDO. So we'll do CDO remap. Now the command remap can be used, can use different algorithms to to interpolate. So if in this case we are going to use bilinear, but there are also other. So if, for example, we use a conservative, you would use, or bicubic, you would use here like remap BIC. But in this case, we are going to use bilinear, so we put BIL. So CDO remap bil, and then I need comma, and then I need now to set what grid I want to use as target. I will use aura.grd, and what file I would like input. So I have this theta, and then an output file. So this input file and an output file, the name of the output file. Okay, so I will add OG, that stands for Aura Grid. Let's try that, and is computing the interpolation. Will take a few seconds. Okay, 8 seconds. So let's check the result. Let's first see if there is the file. Yes, that's the new file here. And now let's check the results. So NC view again. Okay, we can see that this is the same grid as the one that we have seen for Aura, and the interpolation has been performed well, as we can see that there is the Gulf Stream here and Whirlpool and other features. So the interpolation is fine. Again, I can also look at different level, so 310 meters depth, and we can see that still looks fine. Let's close it. So again, let's look at the files. We are done basically with interpolation. So there is one more important feature of the CDO remap that we need to know. If you have to perform the remapping for over tens or hundreds or thousand files, you would know, or even just 10, you would not use the remap bil command as we used. What you would do is you would split this operation in two phases. One is the computation of the weights, the interpolation weights, which is a matrix that is used in the interpolation procedure. And the second phase is, once you have this matrix, you would just apply and perform the actual interpolation, but in a way which is much faster. And so you would save a lot of time. This is because the computation of the weights is it takes time. But if you are producing the interpolation, if you are interpolating similar file from same source and target grid, you would compute the weights only once. So let's see how this works. So I would use our file here. So the command is CDO gen bil for bilinear. If it's BQ or other, you would say gen bic or others. Now you would use aura.grd, and then you would use the input file and the output file, which I would call w_mpiom to aura.nc. Okay, now we are building these weights that we are going to use with the command CDO remap. So CDO remap, and now I will not specify the kind of remap, the algorithm that I want to use for the remap, as this is already specified by the file that I'm going to use for the interpolation, the weights file. So again, aura grd, and now I need an extra input, which is the weights. Okay, we have the weights, and Okay, we are all set. We need the input file and an output name. Output or grid.nc. Let's see if this works, and this would be faster than the previous remap, which took about 8 seconds. Now we just needed 4 seconds. So if you have to perform this interpolation with multiple files, we will save you will save 4 seconds, which is half of the time. So that's all.